Alright class, today we're going to be talking about logarithmic expressions. So before we get started, let's just go over logarithmic expressions and what they would be converted to if they were exponential. So this is a standard logarithmic expression. You can see the base number is a, the x is the product number, and y is usually the exponent. And then when you convert it to exponent form, a is the base number here, y is the exponent, and then x is the product, just like I said. So here we have one example. Log base 10x equals 2. So let's rewrite this into exponential form, which would be 10 squared equals x. So if we punch that into our calculators, we'll get 100 equals x, which is also the same as x equals 100. That's just the basics to start with. Next we have log base half. 1 over 16 equals y. So here we're trying to find y. So we know if we convert to exponential form again, it will be half to the power of y equals 1 over 16. And so a way to find this is to see what exponent as a number can fit into y, so that half to the power of whatever number equals 1 over 16. So we know that 1 half to the power of 4 equals to 1 over 16. So in this case, y would equal 4. Alright. And then we're going to talk about converting logarithmic expressions into an exponential form. So let's say we have log 3 9 equals 2. So let's just say a equals 3, x equals 9, and y equals 2. So in this case we would write it as 3 squared equals 9. And then if you want to convert like exponential forms into log forms, you can do let's try 5 cubed equals 125. So if you want to convert this, we'll again pretend that a equals 5, x equals 125, and y would equal 3. So in this case we could write it as log 5 125 equals 3. There.
Okay, today we're going to be doing laws of logarithm. There are 3 laws of logarithm: product law, quotient law, and power law. Product law would be log base a m plus log base a n, and that would equal log base a m times n. Quotient law would be log base a m plus log base a minus log base n, and it's equal to log base a m over n. And now the last one, power law, would be log base a m to the power of p, and that would equal p log base a m. Okay, now we're going to do a question based upon laws of logarithm. The first thing you would do is change this to log 9 to the power of 2, and then just write the whole equation after. Next, you would use product law. So, log 9 to the 2 times 9, and then you would also use quotient law, so you would divide that by 3. You would get log 243. And then all you have to do is just solve for that, and you would get, as a rounded number, 2.4. So therefore, your answer would be 2.4.
Today, I'm going to be explaining transformations of logarithmic functions. So here we have our equation y equals negative log base 3 bracket 2 bracket x minus 3 bracket minus 5. So first I'm going to start by graphing our basic function. Our basic function is y equals log base 3x. So to graph this, what we're going to do is first we have to change it to exponential form. Just send it down here. So when you change it to exponential form, it's going to equal x. X equals 3 exponent y. So next we're going to want to make a step chart. So we're going to want to take values negative 1, 0, 1, and 2. We're going to put these into the y since it's an inverse function now. So negative 1. Now to calculate our x values, what we're going to do is we're going to sub in these values into y here. So 3 exponent negative 1 will give us 1 over 3. Exponent 0 will give us 1. Exponent 1, 3. And exponent 2, 9. Now that we have our points, we can plot them onto the graph here. So our first point, 3, negative 1. Our second point is going to be 1 and 0. Third point, 3 and 1. Our final point will be 9 and 2. So this is how our basic function graph will look like. Our asymptote is 0. And our range will be y equals all real numbers. The domain, x equals all real numbers. X must be greater than 0. So now this is our basic function. Now we're going to look at how to apply the transformations to them. So in the equation here, we have negative log base 3, 2 bracket x minus 3 minus 5. So what we're going to do, we're going to go back to our step chart here. So since we have negative log, that's our a value. We're going to multiply all the y values by negative 1. And for x, our k value is 2. Keep in mind that when multiplying our x values with k, it changes to 1 over k. So it's going to be 1 over 2 multiplied by all the x values. So our new step chart will look like this. 1 over 6, 1 over 2, 3 over 2, 9 over 2, and 1, 2, negative. Now we have our new points here. But keep in mind we also have negative 3 here and negative 5. So these are our critical points. So what we're going to do with them, this negative 3 will become positive. So we're going to go 1, 2, 3, then we're going to go 5 down. What the critical point means is that our whole graph is shifted 3 to the right and 5 down. Okay, now we're all set up to plot our points. So we're going to plot our new points right here. So 1 over 6 to the right and 1 up. All right. This is our new graph with all the transformations applied. Where you gonna now? What you're gonna do? You're just gonna write down the asymptote, domain, and range. So our asymptote is x equals 3. Our range, y equals all real numbers, and domain, x equals all real numbers. X has to be greater than 3. So that's how you apply transformations to logarithmic functions.
So today we're going to learn about solving exponential equations. And our equation is going to be 2 to the power of x, bracket, 4 to the power of 2x, bracket, equals 8. Now, the first thing we got to do is make all the bases the same. So we have 2 here. We're going to make 4 to the base of 2 as well, which will be 2 to the power of 2. But here we also have this little 2x over here, which means I have to multiply, equals 8. Now, after multiplying, we're going to get 4x on top equals 8. And then when we multiply, we know that we can add our exponents together, so that's going to give us 5x, because x plus 4x is 5x. Now, to make 8 to the base of 2, we're going to change it into 2 to the power of 3. Now, we have the same bases, therefore we can just calculate what the exponents are. As a result, x is 3 over 5. Now here is how you solve a log equation. On the left we have log x, so we're going to bring that down to the next line. And then for all of these terms on the right, we're going to take away their coefficient by using the power laws. So therefore, since the coefficient is 2, we know that log 10 to the power to 3 can be written like this as well. Now, this one's coefficient is just simply 1, so it's not necessary to rewrite it again. Now, we have addition and subtraction, and we're going to use our product and quotient laws to solve it. Let's bring log 4. And then this will equal log bracket 9 times 16 over 4. Now we can cancel out 4 from 4 and 16, and that would give us log 36. So log x equals 36, thus x equals 36.
So today we're going to be looking at logarithm half-life question, and we have a half-life question here that says 150 grams of a substance reduces to 30 grams in 20 days. What is the half-life? Now for this question we're going to want to use the equation f of x equals a times b to the power of t over h, where a is your initial, b is your rate growth factor, t is time, and h is half-life. So we're going to want to sub in the points we've been given in this question right here. So 30 equals 150 times half. So 30 here is your final product. It's what your substance is reduced to. It's what you end up with. 150 is your initial. 1 over 2 is your half-life. It's your rate growth factor. And 20 here is time, which is 20 days. So we want to get rid of this 150 to get the exponential equation on its own. So we're going to be dividing both sides by 150. So it's going to be 30 over 150 equals 150 over 150 2, 20 over h, which is gonna be 1 over 5 equals 1 over 2, 20 over h. Now we're gonna want to log both sides, so it's gonna be log 1 over 5 equals log 1 over 2, 20 over h. Now we know that we can apply the power rule here by putting this in front of log half, so it's going to be log 1 over 5 equals 20 over h log 1 over 2. Now at this point we're going to want to isolate and solve for h, so we can move h to this side, so it's going to be h log half equals 20 log 1 over 2. Now we can divide 20 log half by log 1 over 5. So it's going to be h equals 20 log half over log 1 over 5, which is going to be approximately 8.6. Now we're going to write a therefore statement. So therefore the half-life is approximately 8.6 days. And that's how you solve a logarithm half-life question.